I told you. Alright, so here I'm going to do the first question. Right, so you have, the question says, find the general solutions. For this one now, we are only finding the general solutions. We are not substituting k. You don't substitute k all the time. It's only when you are given a specific restriction, that's when you start substituting k. But if the question says find the general solution, you just find the general solution and stop there. So it will be square root of 3 times cos theta minus 3 sine theta equal to 0. Right, now here we have a combination of sine and cos. You have never done a trig equation like this before. This is now grade 11, real grade 11. All the trig equations that I've been doing so far, they were not grade 11 work. The only concept which was introduced was the general solution, but they were actually grade 10. So this one is real grade 11. To do this one, you need to remember one of those two fundamental identities that I taught you. Tan theta is equal to sine theta over cos theta. Some questions on the general solution require you to use this equation, whereby you convert sine and cos to tan. So you can create tan here with this equation. By taking minus 3 sine theta to the right, you get square root of 3 cos theta equal to 3 sine theta. Right? Like that. Then you divide both sides by. Now, in this case, if you want to create tan, my suggestion is divide both sides by cos theta. Okay? Divide both sides by cos theta. So what you do, you say square root of 3 cos theta over cos theta is equal to 3 sine theta over cos theta. Okay? Now once you do this, this part here will give you tan. So you end up having square root of 3 equal to 3 tan theta. Alright? Then you can divide both sides by 3, and that will give you tan theta equal to square root of 3 over 3. Then let's bring in the general solution. Okay, from here now, you have a trig equation that you are used to from grade 10. So I've created tan from sine and cos. No. I need to find the general solution. So this becomes theta equal to shift tan of square root of 3 over 3 plus k times 180, where k is an integer. So you end up getting shift tan of square root of 3 over 3. That's 30 degrees. So this will be theta equal to 30 degrees plus k times 180 degrees, where k is an integer. So this will be your answer. This one here, let me use a different color. So this will be the general solution for that trig equation. There is no need to substitute k, because the question only wants us to determine the general solution. So you stop there. If the question has got 5 marks, you get your full for 5 marks up to there.
So,
Yes.
this is case.
Maybe I'll say yes.
So I wanted to ask, because the question that you just gave us, there was sine and cos, and root sine and cos would make sense. But if I'm going to be a question where it's like tan and sine or tan and cos, where it's
Generally they don't mix sine and tan. If sine and cos value the rest will combine into one equation. Because you can convert either sine to cos, or cos to sine, you can convert both of them to what? To tan. Even this identity, the second fundamental identity, sine squared theta plus cos squared theta equal to 1, sometimes you use it as well. I'm going to use it just now. Change cos, you have to divide the cos by sine, like how I did that. All right, another question may require factorization, right? Like B, for example, right? B, it requires factorization first. Then after that, you might need to find maybe two sets of general solution for either sine or cos, like part B. So you've got 2 cos squared theta minus cos theta, 2 cos squared theta minus cos theta. So equal to, rather, it's 2 cos squared theta equal to cos theta, like that. Right? So when you've got this one now, don't make the mistake of dividing both sides by cos theta. That will be incorrect. What you do is take the cos theta to the left, you get 2 cos squared theta minus cos theta equal to 0. It's more like you are solving an equation like this. 2x squared is equal to x. Okay? If you are solving an equation like this, you need to know that it's quadratic. So you take the x to the left and then you factorize by a common factor. That same concept, it applies here. You don't cancel out the x's or cancel out the cos thetas. No. Right? So the common factor is cos theta. You get 2 cos theta minus 1 equal to 0.
So it will be wrong if I just divide it by cos theta.
Yeah, it will be wrong. Even in algebraic equations, it will be wrong. If you have an equation like this, you take the x to the left and you get 2x squared minus x equal to 0. Then you factorize, you get 2x minus 1 equal to 0, which means x will be equal to 0 or 2x minus 1 will be equal to 0. Therefore, x will be a half. Okay, so you get two values of x there. Because of this 2 here, that's a sign that it's quadratic. So this is also, it's also a quadratic equation, but it's a quadratic with some trig in it. Okay? So take the constant to the left, factorize by a common factor. Then you end up having two equations. The first one, you equate this cos theta to 0. So you end up having cos theta equal to 0 or 2 cos theta minus 1 equal to 0. Which means you are going to end up having two trig equations. So you get a general solution for this one, there are 2. General solution for that one, there are 2. In total, for the whole question, 4 general solutions. Okay? So for this one here, it will be theta equal to plus or minus shift cosine of 0 plus k times 360, where k is an integer. Then shift cos of 0 is 90 degrees, so we get theta plus or minus 90 degrees plus k times 360, where k is an integer. So I found the first 2 general solutions. For which equation? This one here. I'm still yet to deal with the second one. So to deal with the second one, I'll do it on the next page. I'll simplify that by making cos theta the subject in that equation then. 2 cos theta minus 1 equal to 0.
So, why did you solve that one?
I'm going to do it. Then, so 2 cos theta minus 1 equal to 0 becomes 2 cos theta equal to 1. Then you divide both sides by 2, you will get cos theta equal to a half, which can easily be simplified to theta equal to plus or minus shift cosine of a half plus k times 360 degrees, where k is an integer. Yes? Why would you want to convert to a decimal? No, it doesn't help you in any way. So it's better to work with common fractions, always. So this becomes theta equal to plus or minus 60 degrees plus k times 360, where k is an integer. And then you stop here. So the second set of the general solutions. So we have got total of 4. Okay.